Good evening, sir. This is Sayam Chaudhary with my teammate Shruti Chauhan, and we'll be delivering a presentation on our topic courier and delivery services.
So our problem statement is, as in the current logistic process, parcels are returned to distant sailors, resulting in increased delivery times and costs. So in order to deal with this, we have optimized this process by utilizing warehouses which are located between sailors and customers. We have developed this decision-making framework considering all the important factors like cost saving, warehouse utilization rate, and customer satisfaction to determine whether a parcel should be kept in the warehouse or not.
So we have divided our main objective into three subtopics, which are cost saving, warehouse utilization rate, and customer satisfaction.
So first, firstly we have cost saving, which depends on transportation cost, fuel cost, warehouse cost, and labor cost.
The transportation cost is basically the vehicular cost per unit kilometer into the distance it has traveled while delivering the product. The fuel cost is the fuel used while delivering the product. It is basically the distance upon mileage into fuel cost. The labor cost is the cost that the labor took while loading or unloading the product plus driver's cost. So the warehouse cost is the number of parcels kept in the warehouse multiplied by parcel cost plus warehouse rent plus the number of parcels that are not kept in the warehouse into the return cost. So the total cost is basically the summation of all these four.
Now we can simply calculate cost rate as the cost of sending parcel back to the seller minus the total cost of keeping it at the warehouse into number of products. After this, we can simply calculate percentage cost as it is shown in the slide.
So now we'll be moving to our second objective, which is the warehouse utilization rate.
So to calculate warehouse utilization rate, we need to consider four features. Uh, First one is C utilized, which is the storage capacity at time t. C total is the total storage capacity. Incoming feature is a function of time, which represents products coming into warehouse, and outgoing represents products going out from the warehouse.
So we are assuming that the warehouse is a continuous chemical reactor in which the universal law of product conservation can be applied. So basically it is the derivative of C utilized per with respect to time is equals to incoming products with respect to time t minus outgoing products with respect to time t minus C utilized upon duration of t. So the utilization rate is nothing but the ratio of the capacity which is utilized upon total capacity, and this is a graph which we have plotted using the data which we had.
Now, moving on to customer satisfaction, it depends on the following factors. First one is customer rating, prior purchase, product importance factor. It is a factor which determines the importance of the factor as low, medium, and high. Cost of product, discount offered, customer care call, and reached on time is a binary feature which tells us whether the product is reached on time or not.
So the customer satisfaction is nothing but a summation of many different factors, which includes customer care calls and customer rating and many others. We needed to fix it down in the range of 1 to 5, depending the one with the lowest satisfaction and 5 representing the highest satisfaction. So we have used this formula to tone it down in the range of 1 to 5.
After successfully calculating all the three parts, now we'll assume that all the three factors have equal weightage. So we'll calculate a decision metric using this formula as it is shown in the screen. Now, after calculating this metric, we'll compare it with a threshold, and if it is greater than the threshold, we'll keep it in the warehouse, and if it is smaller than threshold, we'll not keep it at the warehouse. Thank you.
Thank you. This was our presentation.